golden brown, texture like sun, lays me down. With my mind she runs throughout the night. No need to...
Okay, number 3 asks, what is the maximum number of x-intercepts and turning points for a polynomial of degree 5? So, there was this little blip, like a box, in the notes part, or in the lecture part of your, of the section of notes that this is in. But basically, what the thing is, the idea behind it was that the maximum number of horizontal, in this case x-intercepts, I guess, horizontal or x-intercepts equals the degree of your polynomial. Degree of your polynomial. Okay? So in our case, the maximum number of x-intercepts is, based on our degree, is 5. Okay? Also, the maximum number of turning points. Turning points means where your function changes from increasing to decreasing or decreasing to increasing. Okay, so the maximum number of turning points is equal to the degree of our polynomial minus a 1. So in our case, that would be 5 minus 1. So our maximum number of turning points is 4. Okay, so let me just draw pictorially what this looks like on the next slide. So for a degree of 5, what that means is we have some kind of x to the 5th graph going on. Okay, and we have, our graph could look something like this. Okay, look something like that, or it could look maximum, in a maximum sense, something like this, okay, where let's say here's our x-axis. That's where it happens to be. So in this case, see how we have 5 intercepts? 1, 2, 3, 4, and 5. So this is the maximum number possible, as well as, let's look at the turning points. So these are basically like the vertices, kind of, sort of. They're just called turning points, but where you change from increasing to decreasing, and decreasing to increasing, and then decreasing to increasing again. Anyways, so lots of arrows going on. I'm just going to omit those arrows because they're kind of confusing. So where I drew the vertical lines, those are our turning points. Okay? So anyways, you can see how we have 4 turning points and 5 horizontal intercepts. Let's try another exercise where we do, let's say, x to the 4th. An x to the 4th graph looks something like a W, kind of, like that. So we could have, well, we could have our x-axis being there, in which case we'd have 2 x-intercepts, or horizontal intercepts, or the maximum number we could have, if we draw our x-axis in the right place, we could have 1, 2, 3, 4 intercepts, right? Which is equal to the degree, right? We can't have any more than that. And our turning points are 1's here, 1's here, and 1 is there. So we have 3 turning points, which is equal to 4 minus 1. Okay, now for the 4th and final question, we have find the vertical and horizontal intercepts of each function, so of the one given below. So let's start with vertical intercepts. So vertical intercepts are when our input, when t is equal to 0, okay? Because our input is t in this case. So f of 0 is equal to 2 times 0 minus 1 times 0 plus 2 times 0 minus 3. So if we multiply all of these out, we get 2 times negative 1 times 2 times a negative 3. So the negatives cancel out, and we get 4 times 3. So that's going to be a positive 12. So our vertical intercept is at 0, comma, positive 12. And now let's find our horizontal intercepts. Okay? So this would be when our f of t is equal to 0. So this is equal to 2 times t minus 1 times t plus 2 times t minus 3, okay? And what would make this be 0? Well, we could have t equals 1, that would make it be 0. We could have t equals negative 2, that would also make it be 0. Or we could have t equals a positive 3, and that would make it be 0. So now we just stick these in, and we say, well, 1 comma 0 is a point, is a horizontal intercept specifically. Negative 2 comma 0 is a horizontal intercept, as is positive 3 comma 0. Okay, so here are our horizontal intercepts. Let me draw that line there, and here's our vertical intercept. All right? So that wraps up our practice problems video on this section on power and polynomial functions. I hope that helps, and good luck on your homework.